Starting in a minute. I hope everyone joined and everyone's requested to please keep their mics off. Anyone's got any question, so they can ask in the end of the session, and we will be starting. Hello, everyone. My name is Kanat Khalid, and welcome to the day one of our machine learning series of Math Club hosted by TensorFlow User Group Islamabad. Today, our focus revolves around essential topic of fundamentals of machine learning, statistics, and probability. We are thrilled to have with us an esteemed expert in the field, Kartikey Rawat. He is a distinguished Google developer expert in machine learning under the GenAI subcategory. He also serves as open source manager at Code Labs, bringing a wealth of practical knowledge and experience to today's session. Without any further ado, let's extend a warm welcome to Kartikey Rawat as he guides us through this enlightening journey into the fundamental of machine learning. Please join me in giving a round of applause to the virtual session and make it an online event. And Kartikey, towards you.
Thank you so much for the warm welcome. And hey everyone, my name is Kartikey, and today we will talk about basically go into the mathematical part or like a kind of give you a glimpse around the basics of mathematics. Just wanted to understand, is there anyone who never heard about or never tried, or maybe know about probability statistics? Just wanted to know, is there anyone, or it's like it's your first time that you are hearing about? Can you tell me in the chat section? It will be better for me to understand the whole audience. Yeah. Okay. Okay. Yes. Okay. Okay. It's your first time, kind of. Okay. Cool. Okay. Cool. So my thing will be more or like two thing. I do a implementation part of it, but first of all, I will explain you what I'm doing and what it is going with it. So let us start with it, I guess. And I guess let me turn on my cam. That will be better for you to understand. Yeah. Cool. So let me share my screen to get started with it. So I am hoping my screen is visible to all of you. Let me check one more time. Okay, cool. So first of all, going into the thing, we have to understand if you want to become a machine learning engineer or you are into machine learning or wanted to get into machine learning, data is really important. And I hope so. There is a lot of session happened by TFEJ Islamabad on the thing around machine learning or data in general, you can say around it. But why mean median mode, or this is kind of a very basic in mathematics, mean median mode, to get you more understanding. First of all, I just give you the major things. Like mean is basically the average value. If you have a lot of data points, median is more like a middle value. You can say average of that particular thing, you can say, or like middle point of that particular value if there's a lot of values. And mode is the most common value, right? So let me give you more better instance on majorly on this thing basically. So let's get started. Let me get out my pen so it will give you more better understanding around it. Cool. So let me go with it. Okay. Yes. Just a second. So cool. I hope so. It's fine. Okay. So suppose let's talk about first of all the mean. And really sorry for my writing. Really sorry for writing if it went well, like that. But okay. So let's talk about mean. So we say like it's the average value of whole thing. So suppose let me make a graph. Okay. And maybe say this like in this format, maybe this is a participant number of participant, and this is the number of event that maybe TFUG Islamabad did. Okay. Okay. Suppose in initial we got around, like let me do like in this format 10, 20, 30, 40. Okay. Same with here. We have like one first event, second event, third event, and fourth event. Okay. So obviously maybe in the first event we have a lot of audience around this. So this is kind of a 1D data. Okay. For second one maybe it's like 20 people, and third one it's maybe 30 people. Okay. And fourth one is maybe suppose it's 10 people. Okay. So this is kind of a one dimensional data that when we considering around it. Okay. And when we say like why mathematics is important and this or that, let me go into that. But first of all, if this is a data, let me connect these dots first of all. Okay, let me change my color. So if we say this is a kind of line, okay, something like that, or maybe let me make it more better. Let's see. I'm really sorry for the drawing part, but suppose this is like this, like I'm just making very sharp at corner, why it is important. So generally those who pretty much involved in maths, or you have basic knowledge around maths, you pretty much know line equation is a basic line equation is y is equal to mx plus c, right? That's the basic, you can say, how I'll say, basic funda to that basically, right? When we say, so let's say y is equal to mx plus c, which to be frank, if I will write in this format, let me change it in the code like this. Okay, so if I will consider, like, let me say just this one basically. Okay, or let me make it more better. So okay, so if you will see here, this part is, you can say, kind of, this is the c, that is the remaining or intercept, you can say the c is basically intercept around it, or like if it not cutted around or not touched to any axis around it. If it is y-axis, this is x-axis. Okay, so this is kind of the minus, you can say, minus intercept. And if you will say, we make it like this way, like, let me make it like a triangle. Is there any question till now? Yeah, intercept on y, basically it's not touched it, it's not cut on any axis, so I'm just giving you a dotted version to it basically. Okay, so that's the basic one, basic thing around it. So slope is more like this line, the how many angle it make with the, maybe with this x-axis, you can say. Okay, because it's just parallel to that thing. Okay, and generally slope is also called tan theta. Okay, which is more like, if I make it name like A, C, and D, and when we say tan theta, I hope so you pretty much know about it's about BC upon AB. Like, that's a basic thing, and that's also called slope. You can say in that term, you can say in that format basically. Okay, and okay, so m is more like a slope. You can say, like, that's what I'm saying. M is equal to tan theta, which is equal to BC upon AB basically. Okay. Now, I'm not going into very basics to that part basically, but this is kind of one-dimensional data, and this is the basic thing. What is the equation of line and all that basically? Okay, but suppose, let me go, uh, let me go here, and let's talk about maybe some two-dimensional data. Okay, so this is a graph, and suppose we are going with cat versus non-cat data. Okay, so suppose blue is cat, you can say. So let me make it like this, like this, like this, like this, some data like this. And suppose non-cat data may be this. Okay, so obviously this is kind of two-dimensional data in the sense of, like, this some of the points it's saying that this part is cat, these are cats, these are non-cats, kind of thing. And how we can, if we are building any machine learning model, how we can understand. So generally, from human eye, we can say, like, we can make it like, if we can make a function something like this is, but this is not possible in general, right? This is not how any, you can say, how basically a computer understand this. Okay, to make that thing, we came on the thing, or we, how we can make this kind of graph. This thing actually called activation function. Okay, I hope so this is the basic thing, I guess. If you, if many, like, if maximum people tell you about, all those who are old session, if any machine learning take, obviously you pretty much know about what is activation function. That's mathematics came into play. What kind of equation should we have to put it so that it makes something like this? That's a major thing around it. Okay, and here only we have to understand how, what is data, what type of data it is. So we have three, that is I already say mean, that is the, maybe if I will say suppose in that format, like let me go back with, okay, so suppose let me make this, if I stretch this line in this format, okay, and it's kind of in the sense of like, if I'm just going with a simple linear equation, that is y is equal to mx, okay, for now, or like to be more better, y upon a plus, sorry, x upon a plus y upon b is equal to 1. That's also one form of equation basically that we are using here, okay. I'm not going into the depth of the linear equation and that particular equation, or how this equation came into play. If you explore in maths, you pretty much know around it, okay. Okay, so this is one take that you can around it, but my major thing why mean median mode is important. So how I'm getting, if I get a point like this is the region, sorry, this is the region, maybe back I guess, this is the region where maximum data points are collected, that came around mean basically, right, where the average value around it. Mode is majorly, you can say, number of common value. If you will see, green pointers have a larger mode, right, we have a, we, why it is really important, because if there is a lot of data on some specific category and we will try to predict something from a machine learning model, that's called overfitting, that we have a lot of data around that thing, and if we ask anything around that, it will answer in this, that only. So on that point, learning is not happening in model basically, okay. So we have to be very specific around what kind of data, or while we are doing data engineering or data cleaning part, to be precise, how we have to do it, so that it should be a balance of data on every category. It's not like 70 images of cat and 20 images of non-cat, which doesn't make sense, because it will not learn very better comparatively to the that particular non-cat classifier basically, because it's a less data, okay. That's why mean median mode came into play. And we back, if we go back to here, okay, and if I go very line to line kind of thing, I guess you pretty much got your point basically, what is thing. And what is an outlier? An outlier is a data point that is significantly different from average value group stats basically, okay. And that's what came into the central tendency. If you heard about if you are into stats or probability, you pretty much know about central tendency, just like of that whole graph or whole data point, what is the central most important feature, or you can say data point, that we specifically going here. So in, if I go line by line, it's defined as the statistical measure that identifies single value as a representation of entire distribution. There's a 50 to 60 people are one, and how we are getting into it, that's a major thing that we have to go. So let's, maybe if I will go to this code, you can do it by how using, there is an inbuilt function in at numpy, and you obviously can sci-fi, you can also use in that way. And what is basically, this is the data point, you can obviously change it around it, okay. And if we run it basically, okay, already I run it, so it's better for you to not to connect that thing, but I will share the collab link with you, so do not take tension, you can try it in your terms also, not a problem in that, okay. And median, if there are two numbers in middle and divide the sum, basically that's basic thing about median. If I will talk about mean, it's like add add all the values divided by the number of that, like how many number of data points we have basically, okay. That's, if I will talk about in the mean, where is the uses basically in machine learning, in data pre-processing, normalization, and imputation basically of missing values. What what do I mean to say normalization? That's, as I already saying, if you have a some category have very less data and some category have very large data, so we have to normalize the data so that it make it like 50 is to 50, or maybe you can say 60 is to 40, in that format. Because if there's some large data in some category, obviously the answer will be on their side only. If there's a lot of data in cat versus if there is a lot of data in cat, in the data set of cat versus dog or cat versus non-cat, then high possibility the answer will be cat only, because they are learning more, because you are putting data more. But obviously large data is also create, that's called a scenario called overfitting, where you also get your training maybe 100% accuracy, which is not possible. If you are, there's a, you can say there is a tip of model performance or improving your model. If you getting 100% accuracy model, then that means you have to understand that is you did something wrong because it's not possible. That's the take of mine around that, because there's a higher possibility, because learning, if a model is learning, it takes so much time to understand the whole thing. And if you're providing so much data to it, so it's not actually become machine learning, it become like a classical computing. It's like 2 plus 2 equal to 4, and again you are asking what is 2 plus 2, so obviously it will give 4, right? Because you already asked that thing, or you already trained that thing. It's more like roten thing. I am learning 2 plus 2 equal to 4, or maybe if I am learning 2 stable, and just asking random question from the 2 stable, basically I'm not asking anything from 3 stable. That means you are underfitting, because data is very less. And if you are underfitting data to a model, that means you are underfitting because data is very less, and it is not fitting to that particular model, basically. That's the major thing came around it, right? Okay, cool. So this is majorly, that's why the commonality came here, like even for the median, it is uses for central value that is very less sensitive to the outlier. When we say outlier, it's more like you understand in that format. Let me give you an example. So so if you go here and let me create again a graph, and there's a lot of data. So suppose it's kind of making circle, okay? In this format, you can say it is kind of making circle. So outlier is majorly the endpoints of the whole graphical unit, you can say, okay? And the central tendency maybe came around, maybe you can say the central tendency came around this side, maybe because we have a large number of data. So that's basically came around the median, or that's called the, basically you can say, the outlier part, basically. Okay, so median is often used to summarize, basically we have to, because there's a lot of distribution happen in data, we have to maintain that distribution so that it can go in that format, basically. Okay, so that's a major thing around it. And with the mode, you pretty much know if you have a common values around it. That's what major thing around it. Okay, now standard deviation. So think is like standard deviation, or like, to be very frank, variance, that came around when we go with the trade-off with the variance and bias kind of. Okay, so that's a major thing that we have to focus around it. Okay, underfitting occurs when the model perform poorly. Yeah, that's why I'm right now focusing on the training. I'm right now focusing on the training data, basically, but not in that terms. I want to understand, like when you're splitting up the data from training to test data set, I'm not focusing on training data set or test data set. I'm just taking a whole pure data set. I'm not saying I'm working on the training data set separately, or testing data set separately. I'm taking a whole as a one and try to make that. Okay. Standard deviation basically is a number that describes how spread out the value is, basically. Okay, and it measures the average distance of data points from the mean. Standard deviation is, you can say, a kind of formula, the square root of variance, basically. If you can say, it's, if sigma is the symbolization to that, so sigma square is kind of that, you can say. Okay, so variance is equal to standard deviation square, you can say in that format. Okay, so a low standard deviation means the most of number are close to the mean. That's the basic thing. How much the mean part, how much the data points are really towards, which gives you more understanding how a whole plot is there when we are plotting any data, how it is going in that format, basically. Okay, and higher standard deviation means that the values are very spread out compared to the wide range. And if you will see, if you will run like I'm just importing numpy and basically passing like an array called speed with some values, and we'll try to mean it. Okay, this is the mean. And then again, if we will try to find out the same thing with some standard deviation, it is greater. So if you will see, the values are very spread out around that thing, if you will see in that format. Okay, so same thing, if you will go with the mean thing, like again we are finding on the mean, and basically it's just like all things are formulas, so you didn't have to basically write your proper function around it to basically made it in, like it's already written. You have to just call or like import that particular thing and use in your system, basically, you can say. Okay, so meaning of majorly thing, if you will see 37.84 from the mean value, which is 77.4, as you see, higher deviation indicates that the value is spreading on a wide range, basically. That's what the major thing, right? Now, variance. So variance is another number that indicates how spread out the values are, but it measures the average square deviation. It's more like square root. You can just, if you heard about root mean square, with the mean variable, with the comparison with the mean thing, how you're getting more data very accurately, it gives you that instance basically. So it basically averages the square deviations basically of each point from the mean of data set, you can say. Okay. Now, in fact, if you take square root of variance, so why I'm comparing, or you can say creating an analogy between mean and root mean square, or you can say standard deviation and variance, because it's obviously kind of related to the same. We are taking the average of the square root of the mean basically. That's what we are doing here. Okay. Same thing. If we find out the mean here, we got something like this. Okay. And then basic how we did it basically. Okay. So we taking a mean, and then we find out, before here we are kind of creating the difference between the values between the different points. If you will see, I'm creating, it's more like I'm creating a frequency around it. What are the cumulative frequency or normal frequency between the data points? That's what is there basically. Okay. And for each different square, like we are kind of squaring that part basically, what is the difference between it, and we are squaring that part, which gives you understanding what are the variance out of it, and we are dividing that thing with basically, you can see the average, the total value is like 7, so we are dividing by 7. Okay. Same thing, like we are creating a speed, then we are numpying, converting into the other for the variance, it will give around this. Same thing with some data, we are basically splitting up all the data, how it goes around. Okay. And we will kind of give you the kind of same thing with variance and the standard deviation part basically. Okay, this is what we are doing basically. We are taking the square root of, we'll kind of give you a same answer if we're comparing that thing with here. You can say this one, kind of same thing, because for the variance part we are just have to take an under root of that, and we will get that thing basically. That's the major thing. Okay. And standard deviation and variance are two key features commonly used in the financial sector. So standard deviation is a spread of the group of members from the mean. Okay. The variance measure the average degree. So what is the meaning of average degree? If you heard about by any chance in physics, like degree of freedom of degree, you can, yeah, degree of freedom, whatever you have to say. So let me go in this format. Okay, so each data point how it's affecting the nearby region, you can say this region basically. That's called a degree of freedom, like how it basically make it more like in that part basically. Okay. It's obviously onto you, like it just go on the thing of, I'm not getting into physics into it. It's just like how a single data point affect the other region by data point. That's what we are right now focusing around it basically. Okay. So these are two concepts useful, significant for the when you are basically doing, you can say predicting in the trading part. You can stock market data set is already present on Kaggle. If you want, you can explore it. And this is what we did. Generally, we will use mean median mode and standard deviation variance to understand if I'm on that particular data point, what in before and after data point will work around it. That's what how a trading or like general trading algorithm works around it basically. Okay. Okay, let's go to the permutation combination. Just by any chance, is there anyone who didn't know about permutation combination? Can you drop in chat? Okay, there's some question asked in the okay, cool. Okay, cool. Cool, cool. Okay. So, to give you a basic in a basic line, what is permutation combination? Think more like what are the arrangement of that particular thing, and like, so let's go with the first thing with the permutation basically. Okay, my voice is breaking. Let me know, folks. Okay, let me know if it's everyone, or like is it? It's clear. Okay, cool. And that's fine. Okay, cool. So cool, great. Thanks for that. I hope so. Maybe those who are not, maybe you can reconnect that possible, I guess. So yeah. So permutation, and let's go jump right to the permutation basically. So obviously permutation combination, we in short form we say PNC basically. It's to understand better, it's just like how suppose, let me give you more better an example in this. Okay, so this is called kind of called circular thing, but like let me give you. Okay, so if you will see, suppose this round table basically, obviously, six people. Suppose you can say this is male, female, male, female, male, female. So maybe we can ask how many times maybe this have to move so that it can reach to the this opposite side. Maybe like we have converted it to male. Like basically, we can say in that format. So you can say in that case you have to understand. So what is permutation? Like when we say what is permutation and where have to use it, permutation is just to selecting the object, yeah, you can say data from a certain group, and it is said to be permutation. Okay, or to give you more better, it of object from larger set without considering any order. In permutation we are setting an order, maybe setting order, you can say from it will go from you can say clockwise, this, then this, then this, then this, then this, and then this. Okay, but in the combination it is not, it is very unsorted, like you can choose, it's without a basically in any order, you can say in that, you can say in that. Okay, and if you say what is the formula to it, I hope so you heard about factorial. I just wanted to understand, is there anyone who didn't know what is factorial? Let me know. Is there anyone who didn't know about factorial? I hope so you did a basic programming on factorial kind of thing in your, maybe in your college and all. Let me know. Is there anyone heard about factorial? Yes or no? Can you tell me in the chats? Okay. Good. Okay. So those who even, I guess I heard about one to two. Those who didn't know, just understand in this format. It is written in this n factorial, and what it is more like 1, 2, 3 to dot up to n. So it is more like n factorial kind of written as n into n minus 1 into n minus 2 into this. Basically, it's a multiplication till at the end. I hope so. This is the basic. Okay, obviously those who didn't know, I'm just giving you that. Why I am saying, because when I give the formula to the basically permutation, right? So it is something like this is the permutation thing, NPR, which is n factorial upon n minus r factorial. Okay, that's a, yeah, basically. So this is a kind of formula, and when we say and when we say combination basically, or you can say combination, so its formula is, it's kind of same, but we have just to add one more thing, which is like we say NCR. So everything will be same. It's just like I'm adding r factorial and n minus r factorial. So you can say kind of maybe this r factorial into NCR is equal to NPR. Basically, this is kind of thing that you can say it in that form. Okay. So let me give you better understanding here. So let me share this here. Okay. So I guess you get the formula around it basically. Okay. And this is the for, if you understand ABC. Okay. I am going very random. It's not I'm stating any flow. If in the question or in the thing, like you have to focus on the thing, how we're going in that format. Okay, so that's a major thing that became like ABC, A, B, B, C, C, A, right? We are not following any particular fashion around it. So in the same example, if we have distinct points of permutation combination for A, B, and B, A are distinct items. That is, two distinct permutations for selecting A, B, and B, A are the same. That is like if you will say A, B, and B, A, it's kind of same, right? It is, so that is same combination, but in permutation you can't do it. It's if it is, if I will write AB and BA, then it's not permutation, it's combination, because AB already had it. That's a major thing. So let me give you, I guess someone is explaining explain this n and r in circle diagram. Okay, so let me go here. So suppose I write 3C2. Okay, suppose, so if I'm saying 1, 2, 3, okay, these are 3 points, and how suppose it's A, B, C. What I'm saying is I can write, if I'm basically comparing this thing, if I'm basically making it stagnant, suppose I'm not changing C, I'm just changing A and B. So it obviously sound like AB and BA, right? We have two combinations around it. Okay, but when we say permutation, it should be one, like if I will write A and B, if I write first time I will write A and B, I'm talking about permutation here. Okay, I can't do another permutation called B and A because it is already done, it is taken basically. In the combination, this is a basically a line, this is a basically difference between a permutation and combination. You have multiple combinations of different, maybe if I'll say dice, we have, suppose let's go to the thing, like we have obviously 1 to 6 now digit, obviously, right? For every number we have 1 upon 6 probability, right? 1 divided by 6, 1 upon 6 basically. And but my major point is, if one has came, it shouldn't come in the it shouldn't come in the next time, because it already came, it is come out of the thing. Let me give you more better. So suppose this is a space 1, 2, 3, 4, 5, 6. So upon the first time, it is already taken from the space, that is one is already used. I can't again use the again, like we will suppose another, if I roll a dice again one has came, so obviously it's not a part of the system because already taken out. This is called permutation. But in the combination, obviously one can came 6 times also, right? Even though it is taken out of the system. But here, that's what the difference between a permutation and a combination. Combination can repeat it again and again. There's multiple things. But if one is already used from the space, it shouldn't come again and again. That's basic thing between permutation and combination, to give you better understanding around it. Okay. And again, this is the formula, n factorial upon r factorial, and basically npr is equal, that's why r factorial is added to it basically, because when we say permutation, it's already adding the rth term to that particular, it's multiplying ncr basically, right? That's what permutation, like the formula give you a better understanding upon that basically. Okay. So again, this is the main thing. I'm using iter tool basically for permutation combination, passing a data. Okay, and I basically doing a normal loop for the permutations of these permutation, and same thing with the combination part basically, right? I'm getting this 1, 2, 3, 1. If you will see 1, 2, 3, 1, 3, 2, that is the same one. This is permutation, right? That's you're saying. But with the combinations, you are going with a back and forth around it. That's what the major thing around it. Okay. Now, just talking about, if you wanted to know iter tool, I just read it out for you. I just basically copy this thing from their docs. So I'm not getting to the library more. So it is a module that provides various functions that works on iterator to produce complex iterator basically. Iterator is just like when we are looping out the whole system and all, just what give you an iteration basically. Here you can say in that form. Not going that, if you give you if you want to give you a summary, this is the summary. Permutation is meant all member in order, and a combination selection of the member from a collection of the things basically. Okay, that's a basic major thing. Now let's come to Bayes theorem. That is the, I guess, the most important thing in stats basically, stats and probability basically. Okay, so Bayes theorem has a comes a concept like, if there is an event. Let me go on the this part, give you more explanation. So first of all, it is a theorem came around to think, if an event A is already happened, and we are finding the probability of B such that B is depend on this A. How we can do it, like how we can understand that thing. Okay, so think in more like in this format. So let me give you first of all the thing upon this thing, probability of A cross B. This is called kind of, where A, here is, I'm kind of do it opposite. So let me, okay, let me get, so here A is dependent on B. That means A, we have to find the probability of A where B is already done. So it should be remember B is an event which is already done, and A is basically focused on this thing basically. Okay, and the probability basically came in probability came in this format basically. So probability of B slash A into probability of B divided by probability of A. Okay, this is the basic formula, you can say. Okay, oh sorry, really sorry, I guess I did it wrong. Let me make it just opposite actually. Really sorry for that. This is A. Okay, and the down one will be the B one. Okay, now like you have obviously many thoughts what actually it is this. Okay, and this is what I give you in the uh, this one basically. Let me share the this is the formula basically, kind of that, and what I'm working on basically. So P of A and B are the probability of event A and B. Also, PB is never equal to 0. Why I'm saying it's never equal to 0? Because the event is already done. Basically, there's some probability with that particular event, but this event is already done. The reason is being this is a case you can understand in a machine learning also. Suppose there is we are training a data which is already done, right? We are training a data on the basis of we have some particular data, and we're trying to find the probability of ours basically. If this event is already happened, what will it will affect to our event? Suppose COVID happened at 2020, I guess, right? Before that, online event is very less. So as soon as COVID happened, the increase of online event rise up, right? That's what the thing. It depends on the another event which is already happening or happened basically. That's what the Bayes theorem comes around it basically, and it works on the conditional probability. What is the meaning of conditional probability? Let me give you more better understanding here. Suppose so conditional probability basically works on the thing like you can say how I can explain that. So it will work on the thing. So suppose this is probability of A and this is probability of B. It is unjoined, that means it is not related to by any chance, not any chance basically, it is related to anything. But if I did something like this and there is some intersection happening here, right? Basically it's showing it depends on something, right? That's a basic thing behind it. It depends on something. Okay, so we something called maybe we something called this, maybe if I do an intersection, right? When we write probability of A intersection of B. Okay, what how we can write this maybe in this format basically. So how probability of we have to find the probability of A which depend on B. Okay, and multiplying, so which basically give you an intersection, that major part basically. That's what the formula is, you can understand. You can do more graphical part to it, how it basically going in that also, but it depends on that format basically. Okay, and this is how it totally works around with the like if you will take same thing with different things. Suppose I make it again with probability of B intersection of A, probability of B by A into probability of A. Cool. You can add these things. Okay, it will basically you can add obviously. Okay, or you can compare with basically both the side, or like you can compare it. You can, that will be better because these both are same at the end of the day, right? The intersection, right? Is the basically intersection, nothing else basically. Okay, so how we can do it? Like just compare both the things, so it will be like you can say probability of A by slash B, probability of B, and if we have to find a probability of B depends on A, which gives you formula of this. This is basically a Bayes theorem. If we find this, is what I already show you, right? At the above, you will see. I guess sorry here, right? Yeah, this is what we are doing at the end of the day. I hope, and the Venn diagram obviously helps us to understand what is that and what is this and that basically. This is what we get, and if you want to, if you want to, I already I taken this note from one of my team, a lot of days better, but I did this during my college time. So if you will see, there's a conditional probability which is in hypothesis and evidence. You're not able to understand what is written, but that's why I make it through overall through with the Venn diagram basically. And this is what actually I'm doing, taking both equation one and equation two, comparing it, and just basically comparing like what is the likelihood. This is the postal, though this is the you can say English terms which doesn't matter. At the end of the day, think more like I need to find the probability of A which depends on me, and how we can find out. That's a basic thing around it. Okay, this is what this is. And if you will understand, this is the basic same thing we are doing, like comparing, like taking a disease, like if this is the probability of 0.1 and 0.90 if positive, if there is a disease, given disease, this is a
Sure.
probability which is depend on this part. If suppose the if we find out what is, if this not a disease, then obviously it will be 100 minus 0.01 basically, right? And it depends on no disease. That's the thing, and we can find out the different of B positive or given disease kind of thing. This is the same thing formula that I already used it, and it will give, it's basic mathematics, nothing I'm doing basically. So obviously you can go through the explanation. I did the same thing. I will share the collab link with you if you want. And this is the base theorem you have to understand if you want to understand in that way basically. Okay. And cool, so this is the thing. I hope so this is my end of the, because this is the major thing that I have to explain in that format. Let me take some question of that. Elaborate where please where we use this. I already shared, like in machine learning what I am actually sharing is like an event A already happened, and we have to find the probability of B event, which is depend on A event. This is something like machine learning. If you can relate to it, we have a training data, we have test data, right? We train something which has already happened, and we try to test that thing on the on maybe on we basically trying to test on the training data set, right, to find the accuracy of the model. It is something sound like base theorem if you will understand in that way. And that's what the basic, a very foundational concept of machine learning that's come around the place basically. Okay. Sir, sir, I want to use I want to understand how this concept is implemented in the AI model. I hope so you get the understanding what I'm sharing, right? This is the basic thing basically. And if you want to let me just give me a moment. If I also, if you need all the resources, we actually I'm also organizer of one of the TFUB in India basically. We are also doing study jam. I already done this thing on study jam, so you can find out on the GitHub repo. It's the best thing you can go with it. Okay, still we are updating our repo, but like this collab, this link is already over there. I guess let me give you better, obviously this is not directly we will able to get it. Just give me a moment. I guess there's a day three. Uh, this part, I guess. I and Tisha basically collaborated, like this one of my teammate basically. So you can find out through this. Yeah. How are combiometrics used in ML? If you will see, actually, if you see the probability, like combination is what, like basically containing different kind. Actually, there is some drop of electricity here in my area, so really sorry for that. I hope so. Like I cleared maximum what I'm hoping. So I'm came from my phone, so really sorry for that. Yeah.
Okay, so I think everyone's done with their questions. I would like to say thank you everyone who joined us for machine learning today. And I would like to extend a heartfelt gratitude to Kartikey for his insightful session, and his expertise and practical knowledge have undoubtedly, helped us a lot with the understanding. And as we embark on this journey into the realm of machine learning, we would be conducting more sessions for your help. And once again, a big thank to Kartikey Rawat and our attendees and everyone who made a success of this event. And stay tuned for more exciting sessions like these. Thank you, everyone. Thank you, Kartikey.
Thanks team for inviting me, and thanks Ali for inviting me. Yeah, see you soon, folks. Yeah, bye bye.